In this video, we're going to talk about rational expressions and functions. We'll first start with the division property of 0. For any real number a such that a is not equal to 0, 0 divided by a is equal to 0. For example, 0 divided by 5 is equal to 0 because 0 times 5 is 0. And we say division by 0 is undefined. The reason that you can't divide by 0, if I have 10 divided by 2, I can check it back. 10 divided by 2 is 5 because 5 times 2 is equal to 10. But 10 divided by 0, there's nothing that I can multiply times 0 and get 10 because anything times 0 is 0. A rational expression is the quotient of two polynomials. And that is if the denominator of the rational expression is not equal to 0. We cannot use any value for the variable that causes the denominator to be equal to 0. So we want to find all the numbers for which the rational expression is not defined, or I like to say undefined. We want to find the domain of each rational expression, and we want to write those domains in set notation and in interval notation. So we'll start off by setting this denominator equal to 0. X plus 3 equals 0. So if I subtract 3 from both sides, I'll have x equal to negative 3. Now that's the one that makes it undefined. So in set notation, I'll write x such that x is a real number and x is not equal to negative 3. And as an interval, let me make a little graph here. Negative 3 is the one that makes it undefined, so you'll have to leave it out. Breaks it into two regions, the part on the left of negative 3 and the part of the line that's on the right of negative 3. Over here is negative infinity, and over here is positive infinity. Do you see that there are two regions? 1, 2. One region, two region. So writing it as an interval, it'll be in two parts. The part from negative infinity to negative 3 union the part from negative 3 to infinity. It'll take both of those regions because it's in two parts. On our second example, we'll have to set the denominator equal to 0. If I set x squared minus 2x equal to 0 and factor out an x, I'll be left with x minus 2 equal to 0. You see x times x gives us the x squared, and x times negative 2 gives us the negative 2x. And then set x equal to 0 and x minus 2 equal to 0. Here's the first one that makes it undefined. If I add 2 to both sides, I'll have x equals to 2. So what makes it undefined is x equal to 0 and x is equal to 2. So writing it in set notation, I'll have x such that x is a real number and x is not equal to 0 or 2. As an interval, I'll have to make a little number line so I can see the interval. Let's see, 0 and 2 are the omitted points. So I have two omitted points, which breaks it into three regions. Region 1, or breaks it into three parts. The first part is from negative infinity to the 0. The second part is in between the 0 and the 2. And the third part is from 2 to positive infinity. So let's name the parts. The first part is from negative infinity to 0, union with. The second part is from 0 to 2, and the third part is from 2 to infinity. So I've written it in set notation, and this is the interval notation. This is our third example on this one. Let's see, we want to set the denominator x squared plus 10x plus 21 equal to 0. 1 times 21 is 21, so this splits into either 1 times 21 or 3 times 7, but I'm looking for the one that adds up to 10, so it'd be 3 and 7, so I'm going to rewrite it. x squared plus 3x plus 7x plus 21 is equal to 0. Factor by grouping. Take an x out of that first part, I'll be left with x plus 3. Take a 7 out of the 7x plus 21, I'll be left with x plus 3. Take the x plus 3 out of both of them, and when I take it out of both of them, I'll be left with x plus 7. So that if I set x plus 3 equal to 0 and x plus 7 equal to 0, subtracting 3, I'll have x equal negative 3. Subtracting 7, I'll have x equal negative 7. These are the two that make it undefined. These two make it undefined. So writing it as an interval, I'll have x such that x is a real number and x cannot be equal to negative 7 or negative 3. Now writing it as an interval, I'll have to put it on a number line and look at it from negative 7 to negative 3. Notice negative 7 goes on the left because it's smaller. So I'm omitting the negative 7 and the negative 3. So I have 2 points to omit, which divides it into 1, 2, 3 regions. Over here is negative infinity. Over here is positive infinity. So the first region is from negative infinity to negative 7. And the second region is between the 2 points from negative 7 to negative 3. And the third region is here, and it starts at negative 3 and goes to infinity. Okay, let's look at some graphs. We want to determine the values of each. First of all, we want to start off with f of 2. Think about f of x. They're telling you that the x value is 2 and wanting to know what the y value is. F of 2. F of 2 is what? So I'm going to come here at 0, go over to 1, 2, f of 2. Here's the point, f of 2. That's a point that has an x value of 2 and the y value is 1. So f of 2 is 1. Okay, I want to give the domain. So let's look at all these points. Let me erase that little part I wrote so I can start fresh. I'm looking for the domain, how far left and how far right does the graph go. How far left does it go? Well, the first point over here is negative 5, 0. The second point is negative 4, 1. We've got a point at negative 3, one at negative 2, one at negative 1. We've got one, this one is 0, 3, isn't it? So we've got one that has 0. We've got a point that's first coordinate is 1, 2, and 3. So the domain is a set, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we want to find x values for which f of x is equal to 3. In other words, y is equal to 3. We want to find the x value where y is equal to 3. So let's come up over here on the y-axis and go up 1, 2, 3. What are the points that have y values of 3? Well, this one has a y value of 3, and so does this one. So what are the x values? This one is 0, 3, and this one over here is negative 2, 3. What are the x values? The x values are negative 2 and 0. Now we want to find the range. The range is talking about how low and how high. How low and how high does the graph go? How low does it go? Well, if we look at the y-axis, that gives us how low and how high. So the first points have y values of 0. The second points have y values of 1. We have some that have y values of 2, 3, and 4. How low does it go? it goes down to 0, goes down to 0, and then it has values of 1, 2, 3, and 4. This is the last one. I had a little trouble copying this graph. Didn't come out as perfectly as I'd hoped, but we'll start off with f of 4 is equal to what? F of 4. We have f of x. That means the x value is 4, and I'm looking for the y value. X is 4, so f of x is what? So when x is 4, here's the x-axis. X is, so there's 1, 2, 3, 4. The y value goes down here to 1, 2, 3, or we could say -1, -2, -3. So when x is 4, the y value is -3. The domain, how far left, how far right. Let me do some erasing here. How far left does this go? Goes all the way back to there. How far right does it go? Goes all the way to there. So the graph is cooped in between -4 and +4. Goes from -4 to +4. It does not include the point -4 because there's an open circle there. It does not include the point +4. There's an open circle there, hence there will be parentheses around each one. C part, we want to find any value, x values for which f of x is equal to 3. So we'll come over to 3 on the y-axis. 1, 2, 3. F of x is equal to 3. That means that y is equal to 3. So I want a point where y is equal to 3. There's the point where y is equal to 3. And the x value appears to be, if I drop it down to here, it looks like it's -1.5. And the y value is 3. So x is equal to -1.5. The range is how low and how high. How low does this thing go? Let's see, it goes down to here. How high does it go? Goes to here. How low does it start? That's -1, -2, -3. How high does it go? 1, 2, 3, 4. So the range, how low does it go? -3. How high does it go? 4. Both of them have open circles, so we want to have parentheses around both of them. This is Jo Karen Hudson. Thank you, and have a wonderful day.